Okay. Is my screen visible? Okay. So this is the first problem. In this problem, we are given a string and we are told that using this string, we have encrypted it in a way that if we get some character, then after that we append it with some of the characters that are not equal to that character, and finally we again append that character. So basically, suppose I get A, then after this I'll append it sometimes with characters that are not equals to A, and then finally I'll again put A. So we have to find what is the original string given the encrypted string. So this is just a simple implementation problem. So let's look at the code. So is anyone having any doubt in this approach? Okay, so let's move to the implementation. So this is the implementation. I'm taking my string M and S as input, and then I'm reversing my string. So basically, while I have a character, what I'll do, I'll simply check that, okay, if answer plus s dot back, because this character, whichever I got, would have been a part of, like, is definitely the part of original string. And then I'll pop this character from s, and while s dot back is not equals to answer dot back, I'll pop this character. I'll keep, because these are the characters that were appended afterwards. And finally, this is the character which is appended after all these characters. And finally, I can print my answer. So let's move to the second problem. Okay, this is the second problem. In this problem, we have a total of k different deserts, and each desert is numbered from 0 to k minus 1. And the cost of the ith desert is 2 to the power I. So we have n coins. So we have to determine the ways we can buy different deserts. So let's look at, see if my k is more than 30. So what does this mean? There are some more than 30 deserts, right? So, and the cost of the 31st desert will be 2 to the power 31, or let's say 2 to the power 30. So this number is already more than the limit which we have for n. So in those cases, we can just take the minimum of k or 30, right? And if we have, let's say we have n, like our upper bound for coins is n. So what we can do is, let's say we had 5. So we can select any number of these deserts whose cost is less than or equals to 5. So what we can do simply, if we see this in binary, there are five ways, right? The first one will be when I spend 0 coin, I get 0 desert. Then 1, which is I'll get first. Then I have 2. What is binary form of 2? It's 1 0. So here I'm getting the first desert. Then 3, 1 1. Then 4, which is 1 0 0. Then 5, which is 1 0 1. So I can have a total of 6 different combinations of deserts, right? Yeah, I'll discuss E also. So basically, if I
Here,
have, yeah,
hello.
yeah,
Here n equals to 5 and k equals to 30, na?
yeah, K is something more than 30, or K is like K is around 30 or more than 30 right now. So basically, I have 6. So for any n, I will have, forget about K right now. How many ways I'll have for n? N plus 1, right? When n is 0, write its binary form at 0. So when selecting no desert, when you are using one coin, you'll get 1 binary form. I'm writing the binary forms, right? So these are nothing but these are the deserts that you are selecting. If it's 0, you are not selecting the 0th desert. If it's 1, you are selecting this ith desert. This is the first desert. If it's 1. So if, let's say you had something 15. So 15's binary form is 1, 1. Yeah, this is the binary form of 15. So this means I'm selecting the 0th desert, first, second, and third desert. So basically, if you're using some X coins, this will determine a unique pattern, like unique way of selecting some desert. So you can use either 0 coins, 1, 2, all the way till n. So you have n plus 1 options. But now you have to see that whether or not you can select all of these coins or not. Suppose you are given only 3 deserts, 1, 2, 3. So there's no point of having a value which is more than 7, right? If you're using more than 7 coins, you're not getting any extra desert. Is this clear? So basically you have to take the minimum of n plus 1, or how many actually you have, how many of these ways you actually have out of these k. So how you can get, if you have, let's say, 5 desert, so how many ways are possible? 2 to the power 5, right? Either you will select this, either you will select, like, each, for each of these you have 2 options, 0, 1. So for each you have 2 options. So if you have k deserts, you have 2 to the power k ways. So what final answer will be? Minimum of 2 to the power k comma n plus 1. Okay, someone didn't understand n plus 1 part. Basically, if you are using X coins, you have this X is mapped to a unique way of selecting desert. How? If X, you write X in binary form, basically 1, 0, 1, 1, 0. So this is 2 to the power 2 to the power 2, 2 to the power 1. So basically, if you add these, you'll get X, right? So if you're using X coins, you are getting fourth desert, you're getting second desert, and you're getting first desert. So basically, if you, and this is nothing but 8 plus 8 plus 10 plus 8 plus 4, 12, 13, 14. So this is 14, right? The binary representation. So if I'm using 14 coins, so if I'm using 14 coins, I'll be able to get the deserts fourth, second, and first. So if you're using X deserts, there is only one way of getting, like, the number of way is only one, the deserts that you'll get, and that is nothing but the number of ones that are open or that are set bits in X's binary representation. So how many coins options do you have? You have 0. Either you'll use 0 coins, 1 coin, 2 coin, all the way till n. So these are nothing but n plus 1 ways. So, but now you have to see whether or not you can use these coins or not. So if you had like something like this and there are only 3 desert, you cannot use, like, there's no point of using a coin which, like, coins more than a value of 7, right? So is this clear from where n plus 1 is coming? What's this? Okay, so if there are 20 coins and 5 values, so what is 2 to the power 5? 32. And from 20, you will get 21 options. So minimum of these two. So the answer is 21. Is it clear now? Okay, so I'll move to the implementation. Okay, writing these
Hello.
combinations will take some time. If I have to write all these combinations, basically try taking 0 coins. They will be you'll be have 0 deserts. Then take 1 coin, you'll have the first desert. Try taking 2 coins, you'll have the second desert. Try taking 3 coins, you'll have first and second desert all the way till 21. These are nothing but the binary represented. Try saying that, okay, which are the bits open? Is it okay? Okay, let's look at the implementation ones. So basically, x is initially 1, and I'm trying to find 2 to the power k. But after a point, like since k is very big, 1000, so there's no point calculating 2 to the power 1000. So I'll only go up to the point till this x is less than n plus 1, because after that the minimum value will be n plus 1. Right? So keep like I have, or otherwise, if 2 to the power k is less than n plus 1, so the loop will get terminated because of this condition. So once this is done, I can simply output minimum of n plus 1 and x. So let's move to the third problem.
Hello.
Yep.
Can you repeat again that second one logic? I'm not getting.
Basically, you have
Can
some
you tell
desert.
for small test case like n equal to 10 like that, and write the full explanation. Hello.
Yeah, wait. So let's say n is 7 and you have some k. So what are the possible deserts that you can buy using these 7 coins? If you use 0 coins, you'll get 0 desert. If you use 1 coin, you'll get the first desert. These are the coins, and these are the deserts that you are getting. 0 means, like, let's not write 0. There's nothing here. There is one desert, number 1. If you use 2 coin, you'll get second desert. If you use 3 coins, you'll be able to get 1 and 2. Okay, when I'm writing 1, its cost is 2 to the power 0. This cost is 2 to the power 1. Desert 1 is, since those values are 0 index, the first desert will have 2 to the power 0, right, cost. Second desert will have 2 to the power 1.
Yes.
Yeah, okay. So then the this cost is 2 to the power 0, 2 to the power 1. So some addition of these will give you 3. So now 3, then 4. Using 4, you can buy desert number 3. Then using 5, you can buy 3 and 1. Using 6, you can buy 3 and 2. And using 7, you can buy 1, 2, and 3. So these are, so what I'm trying to say, for each of these values, for 0 to n, you have one exactly, like if you have exactly x coins and you have to use exactly x coins, there is only one way to do this. So for each
Yes.
of these values from 0 to n, there is only one way that you can use some, let's say, is x, if x is appearing in between x number of coins. So for each of these, if there is one way, there are total n plus 1 ways that you can get these different deserts, right?
Yes.
So now if you have n plus 1 different ways, but then you have to make sure that, suppose there was not any, like there was not third desert available to you, there are only 2 deserts. So at that point, there is no point in calculating, like in using this coin, right? Even if you
Yeah.
use this coin, you won't get this third desert, even if you use
Yeah.
it. So that's why you have to take the minimum of total number of total possible ways, comma n plus 1. And what is total possible ways? It's nothing but 2 to the power k. Because for each desert, either you, if you have k desert like this, for each desert you have 2 options. Either you will take it or you won't take it. So for 2 options, right? So 2 to the power k. So whatever is the minimum, 2 to the power k is total number of ways, and n plus 1 is the ways, like the number of ways that you can buy desserts using your n coins. So whatever is the minimum of these two is your final answer. Is it clear now?
Yes, bro.
Okay, is anyone else having, like, other than you, is anyone having any doubt in this problem? Okay, sometimes I might miss what you are writing in chat, so you can unmute yourself and let me know. So I'm moving to the next problem, okay? So this is the third problem. In this problem, we are given that there is a maths teacher who is planning to go on a vacation, and he'll only go if there is a possibility for him to have a vacation for at least k consecutive days. And also for all of those days, the temperature should be less than or equals to Q. So what we can do, we have this temperature. Okay, don't annote. Karan, can you, okay, yeah, and please don't annote from now, okay? So there, let's say these are the temperature values that we have. So what we can do, let's say initially our I was here, we'll keep incrementing our J till the position which we have our temperature value less than or equals to Q. If at this position itself the temperature value was more than K, we'll simply not try to increment J, but we'll simply increment our I and continue. So if at this position we found that okay, temperature is less than equals to Q, we'll have another variable J, and then we'll try to increment. So suppose our J is currently here. So each time we'll try to add to our answer maximum of 0, J minus I. This is nothing but the difference between these two, right? This is nothing but J minus I is nothing but the difference between these two. Minus K. What is minus K here? J minus I is the difference, and minus K is the number of possible. If I am trying to end my vacation at J, how many possible options do I have for starting? Yeah, this is basically sliding window or 2-pointer. So basically J minus K plus 1. So these are the, for current J, this will give me the possible number of starting options if my current vacation is ending at J. So these are the possible options that I have with me for, so that my vacation is at least K days, and these are the options that from where I can start different starting positions for current J. So I will go from J, like I'll increment from here to here, and till my temperature at J is less than equals to Q, I'll keep incrementing and I'll keep adding these to my answer. So this is also just implementation. Is the approach clear to everyone? Is anyone having any doubt in this? You can unmute yourself and let me know.
Please, can you explain it once again?
Okay. So basically, if these are my temperature values, right? So if these are my temperature values, and my currently I is here, and at I my temperature is less than or equals to Q. So I'll maintain another variable J, and I'll keep incrementing this J while my temperature at J is less than or equals to Q. So for now, if this is true, what can I add to my answer? Suppose I am trying to find how many possible vacations can end at J, if this is my J. So how many vacations can end? If my K was, let's say 1, if my K was 5, these are all the vacations, right? These are the starting positions. So I can add to my answer J minus I minus k plus 1, right? J minus I is nothing but the length, the number of days between j and I. And then minus k is all those, I'm trying to remove all those vacations which are less than k. And finally plus 1 because currently j is also less than q. So basically I'm trying to find for each j what are the possible options for starting this vacation if I want to end my current vacation at j. And since this number can turn out to be negative, I'll add maximum of 0 comma this value to my answer. Is this clear?
Hello, sir.
Yes.
Sir, I had a doubt in before previous question that, sir, long will accommodate up to 2 power 64, na?
Yes.
So if k is greater than 64, it will overflow, no? In your implementation.
I'm okay. I'm checking here. X is less than n plus 1. N is less than 10 to the power 9. N is less than equals to 10 to the power 9.
Okay.
Okay, so let's look at the code for the third problem. So in this problem, I have nkq as, I'm taking nkq as input. Then I'm taking my vector a as input. Finally, for each, if a of I is more than q, I'll simply increment my I and continue. Otherwise, I'll declare another variable j equals to I, and while j is less than n and the temperature at j is less than equals to q, I'll increment this variable and then I'll add maximum of j minus I minus k plus 1 to my answer. And finally, once this loop ends, I'll initialize my I to the value j and simply continue. Finally, I'll have my answer. Is this okay? Okay, so let's move to the fourth problem. So in this problem, we are given that there are some values, basically some toys that some people want to be constructed, and there are 3 carvers, and each of these carvers will have some values. So basically in this problem, we have, let's say, some values, and there are 3 people, and for each of these 3 people, they'll have some values. Let's say these values are x, y, and z. And finally, this x will select some values. Let's say this guy selected these values. Then this y will also select some values. And finally, this z will also select some value. So then all the selected values of x, what we need is x minus absolute value of these selected values. And y will also select some values. So this is y minus a value selected by I. And then there are some z minus a of I. So we need all of these, like the maximum of these, to be minimum. That is our task. So what we can do, we need all of these values to be minimum, the maximum of these to be minimum. So what we can do initially, like we have to have three people, like we need like 3 values for 3 people, right? So what we can do, suppose we have our array. First we can sort it in increasing order. So then that means that some range I give it to the first person, the second range I'll give it to the second person, and for the last range I'll give it to the third person, right? This is just general. This is just observation that if I sort it, then I'll give some first part of these values to x, then to the second person, then to the third person. So let's say that I gave this part to the first person. So here is a of I, a of l, let's say the leftmost, and here is a of r. So what do you think the person's first person's value should be x. What should be x equals to? So that this is minimized. The difference of all of these values, absolute value with x is minimized. It would be a of L, not a of, it would be a of R. Let's say it would be a of L plus a of R by 2, right? I'll try to have x as average of these two. Yep, it's median. So what will be the difference of these with L of R? So the maximum difference which I can get here is a of R minus a of L by 2 and CL of this, right? This is the maximum difference. If I choose some optimal x here, this will be still the maximum value. That will be the difference between the absolute difference between x and the values in this range. So now let's try to see if I have this, if I know this thing, that this difference, if I've selected this difference earlier, so I can get.
Hello.
Yes.
Can you explain why you're taking that as x and how that is the maximum difference is? I mean, seal of.
You have some values a0, a1, a2, and a3, and these are in sorted order. So what is the value that you will choose some x such that the value of x minus a of 0, x minus a of 1, x minus a of 2, and x minus a of 3, like all of these values, if you choose the absolute difference of each of these, and when you take maximum of these, it's minimized. What will be x? What should be x? X should be at median, right? At mean of these. Because if you try to shift x in this direction, the difference of these value will increase. Otherwise, if you try to shift x in this direction, the difference between this and x will increase. So you will try to keep x at center. That is the mean, right?
Yeah. Okay.
So if
and
x,
what about the difference?
yeah, so then the difference between x and the right boundary or left boundary will be a of R, that is the rightmost element, that is the biggest element, minus L by 2. But let's say one was 1 and 1 is 4. What will you, let's choose 2. So 1 minus 2 is 1, 2 minus 4 is 2. If you would have chosen 3, 1 minus 3 is 2, and 3 minus 4 is 1. So basically, if your boundary, if your length is odd, then it would be CL, right? So 4 minus 1 plus 1 by 2, or basically 3 by 2 CL. This is the difference you'll get, because you can only choose integers, right? X is an integer.
Yes.
If 1, 2, 3, 4, what will be your x if you choose some x as an integer such that the values of absolute values of x minus each of these elements, the maximum value is minimized? You can either choose x equals to 1, x equals to 2, x equals to 3, x equals to 4. In that case, if you choose 2, still you are going to get 2, the difference. And if you choose 3 also, you're going to get as your difference 2. So that's why it's a of R minus a of L plus, or let's say a of R minus a of L by 2 CL. Is it clear now?
Yes.
Yes.
Okay. So now where we were saying that, okay, if we have this array and X person took these values, Y took, second person took these values, and third person is responsible for the values present here. So if we initially decided that, okay, this is our maximum difference, that is going to be for X and all of these values, or Y and all of these values, and Z and all of these values. If we have chosen our difference initially only, so since this element is in first person's range, we can get the what will be the maximum element, right? Corresponding to the difference.
Yes.
So after this element, we can no longer take next element for X. So then this element will go to second person. And for this also, we'll get the maximum element what we can take in our range. And after that, we can no longer take the next element for second person. Finally, we'll get for third also. And once if we are able to get all the way till n, that is the last element, that means this difference is actually we are able to get like allot these people some values in our array such that this difference is achievable final. Otherwise, if our final pointer won't get to position n, that means this is not possible. So now this is a binary search problem, right? We can just binary search on this difference. Like it will be much more clear when we look at this implementation. So what I have done, I've taken my n as input, then I've taken my vector a as input. So after sorting this, initially my answer is 1e9, like the maximum value, and low and high are initialized to 0 and 1e9. So while low is less than high, I'm taking the mid and I'm checking that whether it's possible to have mid as an answer or not. If it's possible, I'll initialize my answer as mid and high as mid minus 1. And finally, I'll output answer. So now what's happening at this possible function? So suppose I got x, I have to check whether the difference x is possible or not. So what I'll do, I'm doing I is initially 0. So this is for the first person. So for the first person, I'm checking whether or not a of j minus a of I plus 1 by 2. This is basically the difference, C. So this is if this is less than or equals to x, that is the difference. I can take next element. I can try to take next element also while j is less than n. Once this condition terminates or is turned out to be false, or this condition turns out to be false, I can no longer give the current element to the first person. So then I'll try to give, I'll make I is equals to j. I is equals to j means the left boundary for second person. So then I'll try to move my j to rightwards for the second person, and finally when this condition turns out to be false, I'll move my left boundary to j. Now this is for the third person. So now then again I'll do the same thing, and finally I'll check if j is equals to n. That means I'm able to iterate through my whole array. It means I'm able to give somehow to all the three persons. So if j is equals to n, I'll return true. That means it's possible for me to have mid difference for the current array. Is this clear?
Yes, yes.
Okay. So let's move to the fifth problem. So in fifth problem, we are given two strings and we have three queries. So for the first query, we can either block a position. In the second query, we can either swap two positions which are unblocked. And finally, in the third query, we have to determine whether the two strings are equal or not. So this problem is fairly simple, but in today's context, like I'm still not sure. Like earlier, I was trying, this problem can be solved straightforward, like it's simply, but I was trying to get it using hashing. But I'm not like, since the test cases are not visible right now, I'm not sure why it's failing. We can use hashing also because we have toString. If this character is removed from both, like this position is removed from both of these, we can simply, but I think, see, the limitation of hashing is if two hashes like string a hash for string a and hash of string a is equals to hash of string b. What does this mean? Like let's first see if these two are not equal, this means that a is not equals to b. And if hash of a is equals to hash of b, this means, what does this mean?
May or may not.
Yeah, a might or may or may not be equals to string b. So this is the limitation, but still I was trying to the possibility that there would have been collision in my solution was 1 into 10 to the power 18. So that's 10 to the power minus 18, but still it was getting wrong answer. So, but yeah, how we can solve this problem? This is a pretty straightforward problem. Since we have both the strings with our initially, we can count the positions at which it is different. Like I tried triple hashing also, but still I got wrong answer. Someone in chat wrote that double hashing. Like I tried to use hashing 3 times, but still it was giving me wrong answer. So I'm not sure that. I don't think that hashing, like I think I'll have to look at the test cases why it is failing. Maybe there would have been a corner test case, but still I'm not sure why hashing is failing for this problem. It's probably because of the collisions. So what we can do, we have the initial 2 strings, right? So what we can do, we can first count the difference. Difference is nothing but the positions at which these 2 strings differ from each other. So now let's look. We can, on the basis of only this variable, we can tell that these 2 strings are same or not. Okay, so for using only this difference variable, we can count the number of, like whether these 2 strings are equal or not. How? If this difference is equals to 0, that means these strings are actually equal. Otherwise, if the difference is more than 1, more than 0, these 2 strings are different. So how to maintain these difference variable while we are actually doing those first and second type queries? So if we are doing a first type query, so we have to block some index, some position, right? We have to block some characters at this position. Let's say this was the position. So what we can simply do, if these 2 characters are not equal, our difference will simply be, we'll just decrement our difference, because now the difference which was because of these characters at position, at this position, this is no more, these characters are blocked, so they are no more in my string. So my difference will be 1 less, right? And in my second query, suppose I had some position P1 here and I had position P2 here. So I can just simply do for this. First, I'll decrement my, before swapping, like before swapping, I'll check, okay, if these 2 characters were different, I'll decrement my difference. Same way here. If these 2 characters are different, I'll decrement my difference. Then I'll swap my at A at P1 and B at P2. I'll swap these characters. And after swapping, I'll simply check. So after swapping, A at P1 and B at P2. So after once I have swapped these 2 characters. So basically my P1 was here and my P2 is here. So once I have swapped these 2 characters, what I can do, I'll again check whether my character at A at P1 is not equals to B of P1. This means that there is a again I have different characters at position P1, so I'll increment my difference plus plus. And similarly, I'll do for P2 also, that whether A at P2 is not equals to B at P2, then again my difference will get incremented. So this way, for all of the queries, I'll maintain my difference variable, right? And once I'm given a query of third type, I'll just check whether or not my difference is equals to 0 or not. Now there is only one thing remaining. Once I'm given a query of type 1, I'm given a time also, for how much time this character needs to be blocked. So what I can do, I can maintain a vector or maybe a map of vectors, or simply I can also maintain a vector of vector. So how will this help me? The size of this will be nothing but q. Why q? Because there are no more than, so let's call it blocked, and the size of this will be actually nothing but q plus 1, because whatever thing gets blocked at time, let's say x, and it is unblocked at x plus t. If this x plus t is more than q, if this x plus t turns out to be more than q, then for like all the time which I will do the remaining queries, this character will remain blocked. So there's no point in unblocking it afterwards. Otherwise, I'll simply push this current position in my blocked off. Let's call blocked off whatever current time was, whatever my current time was plus t, and I'll push this dot push back this current index, whichever got blocked, right? This is position. If this is for my first query, so this way I have blocked my this character, and laterwards I'll just check for if like at current time, if my blocked, if there are some values in my blocked of current time, for all of these values I'll unblock them. And while unblocking, what I'll have to do, the reverse of this thing, basically, that if I'm unblocking, so I'll have to check that if A at this position is not equals to B at this position when I'm unblocking that. Now these characters are coming into play again. So if these two, if the characters at these positions are not same, then again my difference will increase. Earlier I had decremented my difference if these were not equal when I was blocking, and when I'm unblocking, if these are not same, I'll increment my difference. So simply by maintaining this one variable, I can get the answer. So now it's just implementation. Yeah. You can make a query later, and we'll like try to debug it. So let's look at the implementation. So I'm taking two strings A and B as input. Then I'm taking my time t and q, number of queries, as input. So initially my difference is 0. Then I'll increment my difference for each of the positions when my ith character at A and ith character at B were not equal. Finally, I have taken, this can be also like just q plus 1. So then I am taking a vector of this is nothing but for at the ith time, how many positions will get unblocked. Current time is 1, and I'm for each of the queries, first I'll input my type. Then at ith current time, how many positions are getting unblocked. So for all of those positions, I'm incrementing my difference if those characters were not equal. Then if my type was 3, I'll simply check if my difference is 0, I'll output yes, otherwise no. Then for type 1, I'll take my index as input for which I have to block, and I'll decrement if those two characters, like the characters at those positions, were not equal. Then I can simply check that if current time plus t is less than q, this means that after, like, anyway, if current time plus t is more than q, I won't be like it doesn't matter, that character will be blocked for all the remaining queries. So I'm just checking if current time plus t is less than equals to q, then I can simply push this character's position in my blocked. Now if my type is 2, that means I have to do some swapping. So I'm taking x and y. Okay, like someone asked me right now. Okay, yeah, Pratham, you can check, like, probably in x and y you can, like, are you sure? Like, you have to check this also. Basically, you are taking x and y, you take x and y as strings as input, whether x is 1 or y is 2 or maybe 1. So, and these are the positions p1 and p2. So if x is equals to y, that means we have the same string. The swaps will be happening in the same string. So initially, like, first I'll decrement these things. If a at p1 is not equals to b at p1 and a at p2 is not equals to b2, then afterwards, if x is equals to 1, this means this is the first string. So I'll swap my characters at position. I'll swap my characters at, like, for the string a, I'll swap my characters p1 and p2 at position p1 and p2. Otherwise, that means my x was 2. So that means I have to swap the characters at position p1 and p2 for the second string. So if x was not equals to y, that means I have to swap for different, like the two different strings. So either x can be 1, like my x can be 1 and y can be 2, or this can be other way around also. Like in the problem statement, it's not given that x will always be less than equals to y. So this can also happen, right? So if x is 2, that means my a is for like p2 is for a. So for that case, for like taking that case in consideration, if x is 2, I'm swapping my p1 and p2, and then I can just swap my characters at a, the place at p, like p1 with character for a and p2 with character for b. I'll swap these two characters, and finally I'll I'll add these values to my difference, and then I'll increment my current time. So by maintaining only this variable difference, I'll know for each of these type 3 queries that whether the two strings are same or not. So is this clear? Okay, someone wrote that they have missed the code from problem 1. Yeah, after the PCD session, probably one of the managers will share the code links with you. Yeah, I'll share all the codes. You'll get all the codes. So this is, everybody understood this, right? Is this clear to everyone? Okay, so I think we can end now. Okay, bye.